Hi, I'm Ashay. I'm an engineer by training and a storyteller by passion. I made this podcast to talk about data science, but no math, no equations, just intuitions behind data science. The episodes are not in any particular order, and you can just tune into any episode and listen to something related to data science. Let's get started. We have to understand that whenever we have data in front of us, that data is available in some finite sample space within an infinite population. And whatever we are trying to do with the data, we are trying to understand the behavior of the population. Now, as we have seen in some other episodes of this podcast, we do couple of things. We can do couple of things with the data. We can either understand the behavior of the data within its sample space by calculating sample statistics, or we can figure out correlations between the variables of the data to predict the behavior of the data in some other sample space in the same population. Now, whenever I say in this podcast a variable or attribute or a feature, think of it as basically in a spreadsheet, each row is a data object and each column is a feature, attribute, or a variable. Now, when you are trying to find correlations between variables, there is usually a dependent variable, and then there are several independent variables that contribute to the dependent variable. That's how linear regression works. Now, when you find correlations between variables within a sample in a sample space, those correlations are only telling you that a change in one variable is affecting another variable, and it is there we also observe a change in another variable. But there is a famous saying within data science that correlation does not mean causation. In other words, we can't, just because we have found a correlation between two variables, we can't necessarily say that a change in one variable is causing the change in another variable. We can only say that the change is correlated with the change in another variable, but we can't say it is causing the change. To understand the causality of variables, what you need is a control sample. So let's understand what a control sample means. So you have a data in a sample space, and you want to understand the causality of one particular variable on the behavior of the data. So in ideal world, what you need to do is you need to gather data in a sample space where the variable does not exist, the variable that we want to find the causality of, that variable does not exist. And we need to find data, gather data in another sample space where we introduce the variable, keeping everything else constant, and then see the behavior of the data in that sample space. Now we have a sample space where the variable is absent and a sample space where the variable is present, and with by comparing these two sample spaces, we can say that if there is a change in behavior in the sample space where the variable was introduced, that change, we can infer that that change was caused by the introduction of that variable. Now, this experiment that we just did by gathering data in a sample space where the variable does not exist, and gathering data in another sample space, keeping everything else constant, only by introducing the other variable, this is called a controlled experiment. And these experiments are possible possibly in science in a lab environment where you can repetitively gather data in the same population. But in society or in reality, this may not be possible. For example, if we need to understand whether an introduction of a law changed the GDP value of the country, in this particular example, we can't have two countries where one country we don't introduce the law and another country we introduce the law, and we assume that everything else was constant within those two countries, and then figure out the causal relationship of that law, introduction of that law, on the behavior of on GDP. And that's, in this situation, since it is not possible to get the control sample with the absence of the variable, what we could do in data science is to create a synthetic control sample. Now, and then when you create this synthetic control sample, you can compare that with the sample that we have introduced the variable, and then by that comparison we can infer the causation of that variable, and that's called causal inference. So obviously causal inference and synthetic control are topics for another episode, but I just wanted to introduce the notion of a control sample, and when it is possible to get a control sample, and when it is not possible, and when it is not possible, what we can do in getting a control sample. Thanks for tuning in. I made this podcast to talk about intuitions behind data science, and we'll talk about some other idea in the next episode. There will be no math, no equations, just intuitions behind data science. See you soon.